So this video is going to go through the homework question, which is on page 43 of your book. It's involving the hemisphere and the sphere. So it tells us the elevation of a hemisphere A and a sphere B resting on the horizontal plane are shown in figure 3.15. So that's our elevation there. The solids are in contact. Draw the plan and elevation of the solids and show the points of contact in both views. So first of all, I'm going to draw my XY line here, and I'm going to draw my hemisphere, which is going to be a radius of 50. And I just pick my center point, say that there. For now I'm going to draw it lightly because I'm going to have a sphere in contact with it. Then the sphere itself then is in 18 mil from the right hand side. And the center of that is going to be a radius of 24. So it's going to be up 24 from that then. And that sphere is going to be drawn in front of it. And you can see that it's overlapping or covering this part of the hemisphere there. So that's going to be hidden detail. So from here, that there is going to be hidden detail and the rest is going to be able to be seen then. So this question is very similar to any of the ones we did before, where we're going to first of all find the object by rotating it out to the side so that we can see the point of contact. Because at the moment, if we were to draw the plan view of this, the hemisphere, and take that center down, take the center of the sphere down, and let's just say I take that as my center point, take my radius 50, my hemisphere, that produces a circle in plan, but the sphere, we don't know where the center point is going to be. So it's going to be sitting in front here somewhere, but we don't exactly know where. So in order to actually find that, we're going to roll the sphere. So you imagine it's sitting somewhere around here. We're going to roll it around the side so we can see the exact point of contact it makes with the hemisphere. So what we know is the radius of the sphere is 24. We know the radius of the hemisphere is 50. So it's going to be in contact with the hemisphere. So the distance of the center point of the sphere is going to be 24 mil away from the hemisphere. So the way we do that is we take the two radiuses and we add them together. So we get 50 and 24, we get 74 as our radius, and we swing an arc from the center. So somewhere along that arc is going to be the center of our sphere when it's right beside the hemisphere. So that distance from there to there is 24, that distance is 24, that distance is 24. So we're basically drawing another arc, but adding 24 on. Now we know as well with the sphere, it's a radius 24, that means it's 24 mil off the ground because that sphere is resting on the horizontal plane. So all I can do is take that as if I roll that sphere along, the height of the center won't change, and it cuts across our arc at that point. And that's what gives us our center point. So what I can do now is I can take my radius 24 and from my center here I can draw my radius 24 sphere like that. As always, the point of contact lies along the center of two circles. If I join the center of that sphere there with the center of the hemisphere there, they meet at that point. So that point there, that is the point of contact when the sphere is beside the hemisphere. So that's going to be important later on. What I want to do now is, I want to take that sphere down to my plan and rotate it into position. We know it's sitting there in elevation, but we need to now take this down and rotate it around until it hits our center point in plan. So the center of the sphere goes down that direction there. We take that radius and we swing it around until it comes in contact with our center line that we had originally in the question. They meet there. So that gives us the center of that sphere. I can take the radius 24, and now what I'm able to do is draw that sphere in plan, the one that I'm missing. When we look down on top, we can clearly see that this sphere is partially blocking that bit of the hemisphere. So when it's rotated around, it's still going to be blocking it. So this part of the hemisphere is going to be hidden detail there. Now we go back to the point of contact, because that's what we need to find as well. The point of contact is found where we join the center of the hemisphere to the center of the sphere, and where they meet is the point of contact. Now that point of contact is with the sphere when it's sitting beside the hemisphere. We want to find it when it's rotated around. So what I can do with that point of contact there is, I can take that point of contact down. I can rotate it into position where the new sphere is. So it's along that line there, or along that arc there. How do I know where it stops? Once again, I join the center of that hemisphere with the center of the sphere, because the point of contact lies along the center of two circles. Where they cross over, that point there, that's my POC, my point of contact. To find that then in elevation, I take it back up. The height isn't going to change because the sphere is still rotating around on the ground. I take that point of contact there across where they meet. That's my point of contact in my elevation. So hopefully that video helps anyone who would have been stuck on that question there.